In the Exercise and Metabolic Disease Research Laboratory, one of the things that we're interested in studying is the relative effects of diet and or exercise on metabolic and cardiovascular health independent of weight loss. In this particular study, we investigated the impact of resistance training and body weight on the antioxidative properties of HDL. First of all, we know that HDL has clearly been documented to be both a marker and a mediator of coronary heart disease risk. In addition, it's important to point out that many individuals who have coronary heart disease have normal or quote-unquote healthy levels of HDL cholesterol. And thus the quantitative level of HDL per se might not be the most important factor when it comes to investigating the role of HDL on cardiovascular health. For example, in a 2003 study, Ansel and colleagues here at the Atherosclerosis Research Unit investigated the effects of individuals who had very high levels of HDL cholesterol on its ability to protect against LDL oxidation. And in all the subjects, their HDL was not protective against LDL oxidation, suggesting that their HDL was pro-inflammatory, and therefore the protective effects of HDL may be mediated by its anti-inflammatory and antioxidative properties, and therefore the functional property of HDL may actually be more important than the quantitative level of HDL. This has led the Atherosclerosis Research Unit and Dr. Nabab and colleagues to categorize HDL as having a property known as the double jeopardy of HDL, which is that HDL in some cases could be protective against heart disease, and in other cases could be pro-inflammatory and pro-oxidative and increase the risk of cardiovascular disease. In addition, there's debate in the scientific literature of the relative roles of fitness and obesity on the relative risk of CVD mortality or cardiovascular disease mortality. For example, Jerka et al., in collaboration with Steve Blair, published a series of papers demonstrating that resistance training was associated with a reduction in risk of developing metabolic syndrome. This suggests that fitness may be more important than body weight in terms of quantifying the risk of metabolic syndrome. In addition, there are several studies demonstrating that exercise interventions may reduce the risk of CVD independent of weight loss. And we've demonstrated this in a series of studies that we've published over the last few years. Keeping all this in mind, in this particular study, we performed a cross-sectional analysis of 90 young men between the ages of 18 and 30 who were categorized into three groups. The first group was classified as lean trained. These individuals had a BMI less than 25, but they performed a minimum of 4 days or more a week of resistance training. The second group, similar to the lean train, was classified as overweight train in that they also train a minimum of 4 days a week with resistance exercising. However, their BMI was greater than 27 and the mean BMI was 30. The third group was similar to the overweight trained in the sense that they were matched for their BMI. They also had a BMI greater than 27, mean of 30, however they did not perform any structured exercise. Our main finding of the study was that the dihydrorhodamine oxidation rate of the individuals who were overweight and untrained, indicative of greater levels of dysfunctional HDL, was higher than both of the trained groups. In addition, DOR was negatively associated with strength, HDL, and sex hormone binding globulin, and was positively associated with triglycerides, oxidized LDL, and indicators of fat mass, including trunk and total fat mass. Thus, HDL exhibited greater antioxidative potential in both of the trained groups, irrespective of their obesity status. This improved antioxidant capacity of HDL may be one of the mechanisms by which HDL reduces the risk of cardiovascular disease. Further studies can use this novel assay to investigate the relative roles of fitness and body weight in the context of HDL's anti-atherosclerotic capacity.